This is quite a common type of eyepiece, which basically if you buy one of these telescopes, you get one of these with it. It's a design called a plossel, and optically it consists of 4 optical elements arranged in 2 doublets. These were a bit of a revolution probably 100 years ago now, something like that, because they gave a really good quality image in what was considered to be quite a wide field of view compared to the kind of eyepieces that both amateurs and professionals used before that. And one of the things that you notice about these is they have a barrel size which is measured in imperial units, and that's the case with all eyepieces. This is a 1 1/4 inch barrel it fits into, and the focuser for most, pretty common these days, is to have a focuser that accommodates both 2 inch and 1 1/4 inch eyepieces. The way that works is you have an adapter for the 1 1/4 inch like so. If you're using a 2 inch eyepiece, you remove the adapter and then you can put a much larger 2 inch eyepiece in the focuser. Now, can anyone tell me why you'd use a 2 inch eyepiece? What's the reason for going to a 2 inch barrel size versus a 1 1/4 inch? That's right. So basically, because there's a limit to the field stock, can only be a maximum of a bit less than 1 1/4, because you've got to allow for the actual barrel. It isn't possible to see the entire field of view through one of these that your telescope can deliver. So you have a 2 inch eyepiece, it can see a much greater field of view. So what tends to happen is, because you use these short focal length eyepieces, high magnification are more for looking at planets. So you don't want a wide field of view for those, you want magnification. But if you're looking at nebula or star clusters, you want to see a bigger area of the sky. So for that, you choose a 2 inch eyepiece. And they will generally have a longer focal length, which gives you, some people get confused about that as well, that you see say this eyepiece here, which I'll bring out. This one belongs to the Society and was purchased for the Zeiss telescope. It's a pretty monstrous beast, but it's got a 2 inch barrel. You think, well, why the heck would you use that? Well, the difference, this has about a 50-degree apparent field of view. What that means is, imagine that your eye sort of perceives the field of view to be a certain angle. So looking through one of these, it appears to be about 50 odd degrees, whereas this one gives you an 82-degree field of view, and it's also, this one is a 28 millimetre, so this is a 9 millimetre, so this is a much lower magnification. You'd think, oh, big eyepiece will give you a high magnification, but it's actually the opposite way around. This was purchased for use on the Zeiss, and the reason you want to use this kind of eyepiece on the Zeiss, because it already has a very long focal length. So any eyepiece on that will give you a high magnification. So even this one gives you over 200 times magnification on that telescope. This one you'd be something like over 300 times, 600 times. So that's getting a bit ridiculous. Yeah, you could use it. Yeah. 600 times. Well, yeah, it would be a really horrible view because, yeah. I mean, these department store scopes, this one somebody dropped off in the library that advertises 750 power. The thing is that usual seeing, you can't normally go much above 200 anyway, unless you get a really, really still night where there's not much atmospheric turbulence. Different if you're in space, of course. The only other thing I wanted to mention is that there's another thing we use is called a barlow lens. This is an example. Here's a GSO one with a 2 inch. You can get 1 1/4 inch ones as well. And this is what's called a 2 times barlow. Effectively, if you combine it with an eyepiece, it doubles power of the eyepiece, or effectively halves the focal length. And you think, well, wouldn't I be better to just buy an eyepiece of a different focal length? One advantage of this is that there's a thing called eye relief. Now, if you have to wear eyeglasses to view, the problem with short focal length eyepieces is that most designs, unless you get to really expensive eyepieces, the eye relief gets shorter and shorter. It means you have to jam your eye up really close. It means it's very difficult to use them with eyeglasses if you've got astigmatism or anything like that. If you just need reading glasses, you just take them off, because the telescope focuser can adjust for that just by winding in and out a bit. So the good thing about the barlow is that you can basically double the power of the eyepiece, but it doesn't change the eye relief. So it's a really good thing if you have to wear eyeglasses. The other reason you use this is for photography. For example, if you're wanting to image planets with a typical amateur scope, the focal length won't be long enough to get a really good sized planetary image. So you throw a barlow into your image train with a camera, and it increases the image scale of the planet or whatever you were imaging. So that's all I wanted to say about those. Oh, just one other thing. I'll just show you something. Somebody left this telescope in the library, which is a really old sort of introductory telescope. And you might notice it comes with a diagonal that you put your eyepieces in, and it looks really small. That's because it's a really strange size that they used to use years ago, 0.965 of an inch. And you may come across these. Unfortunately, you can't really accommodate in one of those scopes unless you 3D printed an adapter or something. But yeah, these things are still around. They were very, very common back in the 60s and 70s and earlier. So it's just a note about those. So over to Steve. Thanks. Thank you.
Thanks, Bill. Maybe. There is said 3D printed adapter for a 0.96 to a 1 1/4. And I printed one of those in order to be able to collimate one of those older scopes. So I could put a collimation tool in there. It's not the most accurate of things, but it does allow you to do it. But you can't actually usually just put an eyepiece in here and put them on the old scopes because there's not enough back focus. So you can't actually get it to focus. So good idea, but you can't really use it for anything other than putting a laser in. But yeah, I'm passing around. It's not the best, not my best print. It was done on a Sunday afternoon where I needed to do something. Okay, so for this session, feel free to ask me questions anytime and keep it fairly freeform. There's not that many slides, but we're going to cover a few topics, and I'm keen to know what you guys want to know. So I've got a few sort of high-level topics. I'll show you a few things. I'll talk about a few things. But if there's something that I'm not covering that you want me to cover, then I can't promise I'll know the answer, but I'll give it a go. Most of you know me, but those who don't, I'm curator of instruments, so my responsibility is to make sure the equipment that we've got is still working. I'm also curator of instruments for Stardome, so that means that I'm also sort of de facto responsible for making sure things like the Zeiss are working. So at the minute, it's not working, but that's another telescope's fault. That's because somebody stole all the copper off the top of it. So we're hoping that's going to be back in operation in not too long, but I mean, it is a fairly major operation to get that back in operation. I'll stop saying the word operation now. There's a few things that you've got to be aware of when you've got a telescope, and it's the sort of things that you need to watch out for, the sort of things that you need to be looking after, and it's sort of broadly grouped into a few topics. First one is shock. So if you drop your scope or it gets a knock, that's not going to be good for your telescope. That's kind of a worst case. Now, this isn't actually the Society scope because I couldn't find the picture of that, but we had a Society scope that exactly that happened to. It was a rental scope. We rented it out, and unfortunately, the person who had it, complete accident. The tripod fell over, and it smashed the scope. Now, that can happen. Unfortunately, with a lot of these type telescopes, the catadioptrics, the Schmidt-Cassegrains like this one, you might be in for just getting a new telescope if that happens, because often the corrector plates on the front are matched to the optics and the manufacturers can't supply. So in the case of the one that we had, we actually asked the distributor, is it possible to get a corrector plate? And they said, no, sorry. We could supply one, but it's probably not going to work. So they ended up insurance and having to replace it. That's really extreme. The most common thing that happens when people drop the telescopes is that they go out of collimation. So most of you have probably heard of the word collimation, for those that haven't. The image on the, if this is going to work or not, possibly not. No, oh, yeah, maybe kind of, there we go. The image on the left is a telescope. It's an image of a star out of focus. If you take a telescope and make it out of focus, you'll see these rings. This one, the rings are slightly offset. This one, the rings are perfectly concentric. When that happens, that means your mirrors in your telescope. So a reflector telescope, for example, has got two mirrors, one at the bottom, one at the top, and it means that the light comes in, it hits the mirror, the primary mirror at the bottom, comes straight back up the tube again. It's not tilted off center, and it hits the secondary mirror. That's not tilted off center, and it goes right up the middle of the eyepiece. If your telescope isn't collimated, and that's the most common thing that will happen if your telescope gets a shock, if you drop it, even if you're taking it around in the car, it can drift out of collimation. You need to do something about that. Now, fortunately, for most telescopes, it's actually really, really easy to adjust. So the classic sort of Dobsonian telescope, a lot of people's first entry into astronomy, has got 6 screws on the bottom, 3 white ones, 3 black ones. Those screws adjust the tilt of the mirror. Well, 3 of them adjust the tilt of the mirror, 3 of them lock it in place. On the front of the telescope, the thing that holds the secondary mirror, again, it's got 3 screws, and those 3 screws pivot that mirror over a point and adjust it. It sounds complicated. For most people getting into astronomy, it's kind of the worst thing ever. I know when I started in astronomy, I had a little reflector telescope, and I read about collimation, and I read about horror stories about people never getting their telescopes in collimation. The first forums I went on said, do not touch those knobs. If you touch them, your telescope may never be usable again. So it frightens a lot of people off. In fact, it's not a problem at all. In fact, I'm so confident that it's not a problem that I'm just going to randomly twiddle all these knobs. So yeah, it's not a problem. Scope like this, easiest tool for visual use at least, is one of these, a laser collimator. It's just basically a laser pointer. Points through a hole with an angled screen on it. And what that angled screen does is it allows the laser beam to reflect back, and you can see the position of it. The way that these work, you drop them into the eyepiece of a telescope, you turn it on, and you can see I've completely ruined the collimation. So if I hadn't completely ruined the collimation, which I probably should have shown you first, you'd see the beam returning back into there. So let me just check. Yeah.
It's actually missing the secondary mirror. It's right on the edge.
It's right, yeah, you can see the spot there. You can see that the laser has missed hitting the secondary mirror. It's not coming back, and it's reflecting off the side and coming out of the end. So by adjusting these...
So my question right now is,
yeah.
what's the best angle to have that collimated at?
What do you mean, what's the best angle?
Well, again, I've sort of been reading some stupid stuff, and they say that if you do it on the flat and you move it, it'll go out. So sometimes 45 degrees.
Oh, so you mean the scope itself, what position to have the scope in? Yeah. It sort of depends on your telescope, and you'll kind of get a feel for it. So you can see, can you all see that laser dot now is pointed straight up into this? So I've adjusted that mirror back so that laser dot's in there. Now these white ones lock the mirror in place. They're basically just screws that hold the mirror cell. As I adjust these, you'll see that it moves. Then I'm not adjusting the collimation here, I'm just adjusting the lock. So what you find is you've got to go around these. If anybody's ever done kind of car mechanics, you know, if you're tightening a cylinder head, you go around in a sequence. What you got to do is you go around and lock that one by one, and you lock it just enough to make sure that the dot goes back, and you keep going around. So to answer your question, once you've done that, if your telescope is of a size where the mirror is going to be nicely locked, it doesn't really matter. Because when you move it, you'll see whether that moves or not. I haven't fully locked it there, so it might move a little bit. So it doesn't really matter. If you want to kind of make your life a bit easier, 45 degrees, I mean, that's a pretty good, reasonable way to do it, because you're going to be using your telescope something around that most of the time. But it is harder on your knees. And I don't know about you, but my knees get less comfortable every year, you know. So make it easy. I tend to, if I'm doing this on a dob, I tend to get a little wheelie chair and go around and then wheel back. For visual, and it's not critical collimation, if you're just looking through it, you're going to be just fine if you just use a laser. There are ways to make a laser more accurate. You can put a laser through a barlow and use a screen that you put on the insides. There's a lot of Google collimator barlow, laser barlow. There's a lot of videos on how to do that. But it is pretty simple. The other step that I missed actually, which is the first step, the first thing to do is you've got to line up, there's a dot on the mirror, and you line up the laser so that the laser's in the middle of the dot.
It's not horizontal if you've got an Allen key, because you're doing your primary and secondary limits. Isn't there a risk that you drop the key down there and bang the...
There is absolutely a risk. So
why are you supposed to keep it?
yeah, so it depends. I have a screwdriver with a cord on it, an Allen key with a cord on it, which is actually a good idea. But if I'm not, so this is a screwdriver. Screwdrivers are Allen keys. Yeah, if you do it straight up like that and you drop a screwdriver in there, your primary mirror is probably toast, and you probably need a new scope. 45 degrees, you're probably not gonna. If it's just an Allen key rather than a big screwdriver, you're probably not going to hit your mirror because it's probably going to slide down the tube. If you do it horizontally, that's the safest. But for the telescope itself, the telescope doesn't really mind. If you've got a really big scope, like a 16, 18 or 20-inch obsession, then probably you do want to worry about that because there's a lot of weight in that mirror and it's going to be moving about. So you probably do want to be collimating.
But usually just those ones, they just hold the mirror with a sling around the outside on a flotation set.
Yeah.
So it wouldn't make sense to not have it completely over.
That's right, because if you were to tip one of those all the way over, your mirror is probably going to tip off. Because it's, and I'll get to that a little bit later. The way that the mirrors are held, if you hold the mirror in too tight, you can pinch the optics, which very, very tiny twist on the mirror, and that does cause a really big effect.
So I've used different theories on how tight you need to get those knobs.
Yep.
Yeah, so one was you sort of hold it gently until your fingers start to slip on it. You don't want to do more than that.
Yeah, finger tight. I mean, it depends on the knobs. These GSOs have got quite chunky knobs. You can get your finger around there. You can get quite a lot of torque on it. Some of the others have got little knurled metal knobs, and they are harder to get a full purchase on. But again, it depends on your telescope. It depends how the lens cell is made, and it depends how the mirror cell is made. It depends how the mirror is attached to the cell. So if the mirror is attached in a way where it's quite firmly attached and you crank up those collimation bolts, you're going to get that same effect where you can twist the mirror. But it doesn't need to be, you definitely don't need to get tools out other than a screwdriver for your secondary. It should be hand tight. And the manufacturer has made those knobs in the particular way that they are, knowing how tight they want it. So if you're finding you're getting a socket set and putting it on top, that's probably too much. But if you find that it's slipping all the time, it may be that it's not enough. But I guess the key phrase is just enough to hold it in place. Any other questions on this one? Yes.
What if we don't have a laser pointer?
Yep. So laser pointer is absolutely the easiest.
Right.
But you can collimate using a Cheshire. I actually have a Cheshire here, or a variant of a Cheshire. So a Cheshire really is just a thing with a hole in it. I mean, literally, it's just a piece of, you can pass that around. Piece of aluminium with a hole in it.
But down there in the old days with 1 1/4 inch focus, and they used to use one of those little film.
That's
film cut.
absolutely.
Drill a hole in one end right in the middle and use that as your sight tube.
I used to talk about that, but nobody has 35mm film cartridges anymore. So.
I used to have modern days. I used to have something like that, which is aluminium.
No, that's aluminium one. So that's really a sight tube. You'll also see a Cheshires which have got a crosshair in there, and it's a similar thing. So you're lining up the primary mirror and the shadow of the secondary, and you're getting all of those in line. So the instruction you get with the Cheshire will sort of show you how to do that. Lots of videos online. And you can also do a star test. Star tests are a little bit trickier on something like this because you've got two things to move. So this, and if you get into some of the other telescope designs, you can check whether it's good on a star test, but actually adjusting it, it's a little bit harder to work out which to adjust. If anybody is trying to do like a classic Cassegrain, I've got a really good link. There is a Cloudy Nights forum post, which is a really good process for doing a collimation on a classic Cassegrain. So GSO make classic Cassegrains as well. Astronomy sell classic Cassegrains. And they're a bit tricky. So there's a process that you can go through which tells you really what you're looking for to do that. And there's probably a whole talk I could do on collimation. So, but anybody's interested, anybody's trying to star collimate a Cassegrain or an RC, I can point you to that post and have a read.
Quick question. Just basically, do the secondary mirror first?
Definitely, yeah. So whilst I showed you demonstrated with, I showed you on the primary, the secondary mirror, the small mirror, has to be done first because everything relies on that. The more accurate you get the secondary, which is basically the laser going in and it's hitting the center of that primary mirror, that's your start point. So if that's off and you collimate the primary, it's still going to be out of collimation. So that's the way to do it. So you're absolutely right. Thanks for bringing that up. That's a really important point.
What's the difference between the black screws and the white ones and how they contact the mirror?
So the black screws are essentially, so you'll hear these talk as collimation screws and lock screws, but you'll also hear them called pull screws and push screws. So the black screws are threaded into the mirror cell. So when you tighten a black screw, you're pulling the mirror cell towards the screw. The white screws aren't threaded into the mirror cell, they push against it. So when I say lock, once you've got the mirror in position, the black screws that pull have also got a spring on, so it's held in a spring. So once you've got it in position and then you tighten the white screws are pushing the mirror cell against the threads on the black screw. That's why it moves it. Some telescopes don't have them arranged equally like this. Some have them next to each other. So you might have a big screw and a little screw. And they're called them pull screws and push screws. Really exactly the same.
So you can't over-tighten the black ones because they have a spring.
No, that's not really true. They are threaded into the mirror cell. So if you crank up the black ones as much as you can, I mean, the spring really just keeps those screws tight. So without the spring there, you would be able to kind of pull the black screws out a little bit and they'll pull against the spring tension. So hang on, just finish this one. So if you crank up either of those, either the white screws that push against the cell or the black screws that pull against the cell, you can twist the cell and you could end up with warped mirrors. So again, just tight enough, as Robert said.
My 6-inch has got together, both together.
Yeah, both together, and it's quite common. A pull screw and a push screw. So it's both exactly the same. The different type of telescope is the Schmidt-Cassegrain, so I got one here, and they only have one mirror that you can collimate. So you only collimate the secondary mirror on a Schmidt-Cassegrain. That's because the mirror geometry means that you only need to change one surface because there's a spherical mirror in there. So with these, same thing, 3 screws to adjust the angle of the secondary mirror, but you can't use a laser because if you put a laser in a Schmidt-Cassegrain where the eyepiece looks down the middle, through a hole in the mirror, it's just going to point back at you. So it doesn't work. It can be used to make sure the focuser is aligned, but that's kind of a little bit out of scope here. The way to do this is with a star test. So Schmidt-Cassegrains use a star test. Now you can use a real star or you can use an artificial star. Simplest artificial star is a bright LED torch with foil wrapped around the end with a pinprick in the foil. You've got to put it about, I can't remember the number, it's about 20 times the focal length away or something, 15 or 20 times the focal length away to make sure that it's in focus. And then what you see that. So you'll see that the rings aren't aligned, and then you adjust it, and these rings will shift one way or the other. And then that's how you adjust them. So these are simple. These seem scary, but actually they're simpler than these to adjust. You just got to get your head into it.
What's the focal length of that?
I don't actually know off the top of my head.
So 20 times that
It's 1250, so it's about 20 meters away. So 25 meters away for that one.
Can you adjust that shadow, thanks, because it's shining right in my eye?
Sorry. We'll turn it off, shall we? Let's not have any laser safety issues here.
That's one thing which when I had a split test screen, I used to use my reticle.
Yeah.
You need a reticle to adjust the collimation.
Yeah, you can do that. So you can use a reticle eyepiece, which has got an illuminated crosshair, to help you see if things are centered. The other thing actually that's really useful to do, if you've got one, is to use a camera. So if I'm collimating, I'll use, this is just a astronomy camera with a lens on it, so it becomes a normal camera. And I'll put that in the eyepiece as if it's my eye, and then I can adjust it on a computer screen. So that makes it a lot easier. If you're doing a star test, if you've got a camera that's set up to do images, so for the camera in the research scope here, absolutely we put it on a star and watch the CCD image coming down, and we adjust it that way. Sorry?
You use the eyepiece at the same time.
Well, if you're using the eyepiece, or you can take that off and do it prime, depending on what you need. So you can either use one of the eyepieces is designed for a camera. So another tool that we use, I'm not going to get too much into this, but if you're interested to see me later, this is a Takahashi collimation scope, really designed for Cassegrain type telescopes, so it can be used on refractors as well. I'm not going to go too much into that, but if you're interested, come and see me afterwards.
How do you know which to turn?
So you turn one, and you look at which way the image moves. So if I was to turn one screw, and it started to move that way, hey, I got the right screw the first time. But if the image started to move that way, okay, I might move it back again, and then adjust one of the other ones. So it sort of depends, and it depends on your telescope, and you'll get used to it in your telescope, what you're looking at, and it depends on what angle your diagonal is on and all of that. But you'll get used to it on your own telescope. And what some people do is stick a little crib sheet on the top of the telescope saying, you know, if it needs to go this way, move that one. If it needs to go this way, move it that way.
The rule is you only make small adjustments.
Absolutely, yeah.
So the other thing I do back for Cassegrain is like a tri-Badenoff mask as an aid for collimation.
So a Badenoff mask is really an aid for focus rather than collimation.
Well, but there's a tri-Badenoff mask which got a slightly different pattern from the
Oh, okay, yeah.
For collimation, but I know it's more accurate than just doing your plain old stars and underlying circles.
It probably is. I'd have to do a little bit of reading on that. I have heard of them, but I'd have to do a little bit of reading, so I don't have the answer to that one. Anything else on collimation?
I've got to make a Barlow mask which also can be used for collimation.
Yep. You can just cut them out. I've made Badenoff masks just by printing them on my laser printer, sticking them together, and cutting them out with a craft knife. They work just fine. Next thing that's going to be a risk to your telescope really is moisture. So probably the first time you might see this is if particularly if you've got a Schmidt-Cassegrain and you observe in Auckland, which is very humid, and you get to the temperatures cooling down, and that's what you see. Basically, you see nothing. Once you get dew on your corrector like that, or even if it's a little bit easier with one of these because your primary is all the way down the bottom of a tube. I've absolutely used the Dobsonian where it's dewed up, or the secondary is dewed over in sort of extreme humid conditions. What you don't do, which is what I've seen, and I'll not mention any names, is get a tea towel and wipe the corrector. I've certainly seen that. It's not a great look, and it will absolutely damage your corrector. So if you have a Schmidt-Cassegrain, this glass surface here is not just a flat piece of glass. It's a lens. It's got sensitive coatings on there. It's got so a little bit like if you have anti-reflective coatings on your glasses, same sort of thing. Anti-reflective to let in more light. So you want to be super careful. I'm going to go over that very shortly. But absolutely don't take any kind of cleaning cloths, even if it's sort of like a microfiber cloth. Don't do anything like that. If your telescope gets dewed up like that, best thing you can do is take it inside, maybe use a hair dryer on it gently on a low heat to let it dry off. Best thing to do really is to prevent it happening in the first place. That's quite easy. In most cases you can get a dew shield, so you can get them commercially. So really all that is an extra tube that sticks off the end. Effectively what you already have if you've got a reflector like that. You can make them. This one's off the BBC Sky at Night website. That one's made out of something like a Milo tin, so covered in black tape. Or you can get a dew heater. So what a dew heater does is it basically just warms up the corrector plate just fractionally above ambient. And if you use that before you start imaging, then you won't get dew on your corrector, or you'll need to go a lot further to get dew on your corrector. Any questions about that?
Just advise everyone not to do what we have a guy here that used to use a tea towel.
Well, that's what I said. Don't use a tea towel. I didn't mention any names, but a tea towel is a bad thing.
The same thing for a refractor.
Absolutely the same thing for a refractor. Don't ever get an optical set. You know, I mean, I know a few of you here are wearing glasses like I do. You've probably at least all had this bad habit of just taking your glasses off and rubbing them on your t-shirt like that. I have. These were expensive. These have got coatings on them. The coatings are stuffed. Bad thing. Bad enough when you've spent, you know, $500 on some glasses. Really bad if you spent $5,000 on a telescope. So just don't do it. Moist.
So when you put on my reflector, I still get a lot of moisture.
Yeah.
Even with the mirror, you know, yes, quite way down.
Yeah.
After I actually put a sheet over the whole thing, which keeps it dry for a while.
Yeah.
And then the dew starts to come in, so nothing goes on top of the mirror over the whole scope.
So do you mean you get dew on your mirror as well? Or? Yeah. Yeah. Yeah.
It just gets really, really dewy. So where would I put where would I put that heater? Would that be sort of around the telescope towards where the mirror?
Really, it'd be where the mirror is actually, if you're going to use a dew heater on something like that. Yeah. But you can, of course, make yourself a longer dew shield. So there's no reason at all that you can't get a bit of cardboard, or actually what I like to use is that high-density foam, you know, like yoga mats are made out of. You get it from Para Rubber. That's really great stuff. It's really flexible. You've got to kind of pre-bend it a little bit so it fits together. You can glue it together. It's a bit of a pain to glue, but you can tape it. That's really good to make a lightweight dew shield. And you can do it. There's no reason you can't put a dew shield on here, take it out to here. Just make it so that there's less chance of that dew sort of settling on the mirror. So absolutely easy to do. And it doesn't use a bit of cardboard. Old cardboard box. Of course, your light coming in here is parallel. So it's not as if you've got to have it splayed out. It can be just a tube. So
I haven't tried actually. I just thought of these scopes. I'm not sure of this model, but the one I have at home has actually got an electric fan on the bottom.
Yep.
Oh, this one has too. I've never really used it, but I wonder if you run that, whether just having air movement helps keep the dew settling on the
may well. It'd be worth a try.
Yeah.
Be worth a try.
I've got one of those. I use the other one, which is my electric power lead. Plug it in there, and it does do that just before, say around about evening time. Plug it in.
Yep. So it's really designed to get your mirror down to temperature as fast as you can. But absolutely, you're going to get air currents through there. You're going to be careful with air currents though, because that might affect your seeing as well. But your seeing is going to be really affected if you've got dew on your mirror. So the lesser of two evils.
That does also get rid of the dew anyway.
Yep. Yeah, I can imagine the airflow around there is definitely going to have an effect. So that's worthwhile trying if you've got a scope with a fan on the bottom. Of course, moisture is also a problem when you're storing your telescope. So it's not only a problem when you're observing. And kind of the worst thing that you can see really is when you get this sort of thing. So you get mold and fungus growing on the inside of your lens. And now that's really hard to clean when you do that. If any of you photographers and you've had lenses in a damp bag or anything like that, problem is that the fungus and the mold eats through the coatings. So even if you could pull your telescope apart and clean it up, you've probably got permanent damage. So keeping your telescope as you store it in a dry location, not too hot, not too cold, not changing all the time, certainly not in direct sunlight, not in somewhere where it freezes, all of those things. The sort of thing where you might keep anything else sensitive that you've got, if you've got a laptop or anything like that, where you would think about where you're storing it. Sometimes we tend to just throw these things in the garage and not worry about it. But yeah, moisture is really something that can hurt. And actually how you store your telescope as well. I mean, who's got a Dobby and stores it like this? that's kind of most people, a lot of people who've got a Dobsonian will store the telescope this way. Why? Because it takes up less room and it's convenient, right? So I've certainly been guilty of doing this. Put it in a corner of a room and it's fine. But you do risk really making it worse for things like dust. So if dust is in a room, particularly if you've not got this your tube covered up, or you've maybe just left even if you leave the eyepiece out and there's a little hole there, just dust in the room will settle. So it's actually a lot better if you've got the room for it to store your telescope horizontal, close to horizontal, even depending on your telescope, slightly down. That just means that if dust is flying around, gravity is going to take your dust away from your mirror. So it's just a little tip. Not everybody's got room for it. It's not convenient for everybody to do that, but it's certainly something to be aware of. It's much better to do it that way. The other thing that can happen while you're storing your telescope, and depending on how you store it and where you store it, is these little guys. So telescopes are a nice, out-of-the-way, warm environment, and what you don't want to do is come back after a period of bad weather, and we've had a lot of bad weather in Auckland, so there's a lot of telescopes not being out for months, and find your mirror looking like this. Because that's going to be really hard to clean. So I got this off the internet, and that's probably the worst that I've seen. I have seen and cleaned telescopes with mouse droppings on there. It's actually the mouse urine that's the problem, because it damages the coatings and damages the mirror. So because it's acidic, so it will eat through the coatings. So there's another reason why storing your telescope on its side rather than straight up might be a good thing, because you get a mouse in the tube, it's not going to be quite as bad. You're not going to get any of that sort of falling down on your mirror. If you haven't got proper covers, or be aware that even if you have got proper covers, these things have gaps in them. So this one, probably a mouse couldn't make it through there, but bigger Dobsonians, absolutely. Mice don't need a lot to get in there. Certainly insects and spiders can get in there, even if you've got a cover on. So a simple answer for that, good old shower cap. So, buy them from Chemist Warehouse, or, next time you go off to a hotel or motel and they're in the little thing, just stick them in your pocket, and great telescope covers. You can use them to cover the front, the back, just keeping a bit of dust out, helping to keep the bugs out.
We'll probably also use those silicone lids.
Absolutely. If you've got one of those silicone lids that you get, that's a great way to do it. Anything that just sort of keeps things out, keeps the tube sealed. And it's just going to make your life easier. Because these things are going to get dirty, right? Your telescope is going to get dirty. When you get it brand new, you look at it, it's all shiny. It is going to get dirty. But you got to sort of say how dirty is too dirty, right? The absolute worst thing to do, actually, in terms of asking that question, should I clean my telescope? And what everybody does, me included, is this. You get your torch, and you go, maybe you get your torch, and you go, oh, how dirty is my mirror? Let's shine this nice light in here. Look at that, it's terrible. Look how bad that is. Right? Feel free to come and have a look afterwards. That isn't even close to where I would clean it. Not even close to being dirty enough for that to be cleaned, really. For most people. There is an argument against it. Some of you may heckle me shortly about that, but there is an argument both ways. Cleaning a mirror is kind of one of the scariest things that we'll do to our new toys. Once you realize, those spiders have got in there, the webs have got in there, or I've left it uncovered, the dust is in there. How do I even do it? And I said there's a lot of forum posts that make you scared of collimating. There's twice as many that make you scared of cleaning your mirror. So where do we start? Well, first of all, don't blow on the pie, but don't blow on your mirror either. Don't blow on any optical surface, because even though you think that you're sort of helping getting the dust off, you'll blow out bits of spit, bits of moisture. There might be anything going on that is going to land on your mirror and make it even harder. So as soon as you get it wet like that, and you're trying to get the dust off, even harder. Don't buy these brushes that people tend to sell and say, hey, use a camel hair brush. Not camel hair, incidentally. It's usually like squirrel hair or goat hair. But don't use them. You don't want to move that dust around on any optical surface. If it's on there, you don't want to be scraping it against it. That dust, which is going to be made up of you know, delicious things like skin cells, but also things like bits of sand, bits of grit, bits of dust is very, very, very abrasive. There's these things. Now, they're okay, but I would say a healthy note of caution with those. So these air dusters that you buy, number one, if you do use one, that's okay. Don't shake it. Definitely don't shake it. It feels natural to get an aerosol can and shake it. No. Definitely don't shake it. The propellant can come out of the tube. Now that propellant does two things. Both one, as it evaporates, it's freezing, so you're getting a big temperature gradient. Number two, it's usually a chemical. It's butane or it's some other hydrocarbon that's not going to be great for your telescope. So use this, but use this with a lot of caution. But definitely have one of these. You know, buy 3 of them. You know, you can go to a camera shop and pay $20, $30 for some of them. You can go on Temu and buy one for $1.45. You can. I've got one in here, I think. I'm sure everybody's seen one. It's not the greatest prop in the world. I've lost the nozzle. But, oh, there we go. There you go. You can pass that around. Oh, sorry. Pass that around. Have a play. Blow it in your face. So a little bulb blower. Really useful for everything. Just getting that dust off, getting the surface dust off, not touching the surface whatsoever. How do I clean it? Go on.
Sometimes you get the blower brush.
You get the blower brushes. The best thing to do is take the brush bit off and throw it away. And just use the blower. If you have one and it's got the brush permanently attached, throw the nozzle away and get the end of like a Bic pen. They go in there really easily. They go in the bulb, and actually it's a good nozzle. But yeah, stay away from brushes. So you've got to the point where you can't really blow the dust off your mirror. You now actually do need to do something. How do we clean the mirror? Any ideas before I give the game away? Some of you know, obviously. Any suggestions on the best way? No? Well, close actually. Throw it in the sink. I'm not even joking. The best way to clean your mirror is to put it in the sink. It is the safest way of doing it. Now, it depends on your mirror, and if you've got a 20-inch obsession or you've got something, you've got to be real careful with it, right? But it's an 8-inch Dobby like that. Easiest thing to do is put it in the sink. So how do you do that? There is a bit of a process. You've got to take the mirror out. You've got to take the mirror out of the cell. So it's usually pretty easy. On these, it's 6 screws that go on the outside. Then you've got a set of, I think it's another 6 screws that hold the clamp in place. And then you can carefully lift the mirror out. Then probably my best advice would be have a plastic bowl, like a washing up bowl that it will fit in. Reason being, the metal sink will be a bit harsh on the mirror if you kind of clink it against it. You don't want to chip the mirror or break it. Put a towel in the bottom, microfiber towel or even a tea towel in the bottom. So when you put it down, I'm sure in this one whether there's one on there. So sitting it on something. And then, yeah. Well, don't use tea towels to clean the mirror, but you can sit it on a tea towel. And then running water. Start off with running water. So it's okay to get a warm to sort of hand-hot tap and have that run over the surface of the mirror. That's completely fine. That's a good thing to do because the water itself is not going to scratch. It's going to lift up the dust that's there. It's going to lift up the dust that's not really stuck. And then to sort of manage the dust that's a little bit more stuck, bit of dishwashing liquid. You've got it in the sink, why not? Dishwashing liquid is sort of the basic stuff, right? Don't get anything that's got moisturizers for your hand. Don't get anything that's got fancy chemicals or vinegar or baking soda. The basic stuff. It's a surfactant. It's there to remove oils and grease. Now, if you go on the internet and look this up, everybody will say, you've got to use Dawn Blue. Now, fortunately, we have Costco now, so you can actually buy Dawn Blue, so feel free to buy Dawn. And I'm not paid by Dawn, but, you know, that's what all the YouTubers say. But it really works, right? So that helps get the grease off. That helps. You can slosh slosh the water over it, and none of this process are you touching the mirror. It's safe as, because you're not touching the mirror. Now, if you can get away with getting all of your dust off by doing that, you've won the game, right? You never had to touch it. You're not really at risk of damaging your mirror surface, and you can rinse it off. I'll talk about that in a minute. Put it back in your telescope, and you're good to go.
I have a question. So when we are removing the mirror from the telescope tube, how should it be positioned? What's the safest angle?
Flat, really. Surface up. If you're cleaning it, it doesn't matter that dust is going to fall on it. Be aware of anything falling over it. If you're doing this in the sink and you've got a container with your dish brush or something on there, move it out of the way. Don't let anything fall on it. Do it without kids around. So that surface is quite fragile. Now, most mirrors have got a coating over the aluminium, so they're relatively tough. I would say relatively tough. You just want to be careful with it.
Yeah, so one thing about this, I know we sometimes you might chip it, but how can we clean that? We can't use a tea towel. Do we use a hair dryer over it?
So this is what I'm getting to. So if just sloshing water over doesn't work, and it might not, right? It just might not. If putting some detergent in there, you don't need much, few drops. You actually don't want to see bubbles. You actually see here, there's a couple of bubbles around the outside, but this isn't suds. So you don't want to, you're not washing your frying pan here, you're washing your mirror. Very, very little detergent goes a long way. Actually, it's a marketing trick to put a big squirt in and have all these suds. Not needed, not even to wash your dishes. The surfactant works very well without there having to be a big amount of foam. It just makes you use it faster. So just a little bit. Cotton balls is certainly one way to do it. That sort of stuff. Don't have to be anything super special. Probably get them from a chemist rather than a supermarket, maybe. But you're kind of looking for this, it being 100% pure cotton. No moisturizers, no additives, no special blah to get your makeup off or whatever. Just pure cotton. And you can use this to help you clean the surface of your mirror when it's wet. So it has to be wet. Never use anything dry. So if you take away anything about cleaning mirrors, never do anything dry. And the way that you would do this is get a cotton ball. You got your mirror in the water. Wet your cotton ball from the center or to the center. Just do it in one direction radially. The weight of the cotton ball. You're not pushing down. You're literally letting the weight of the cotton ball pull across the mirror. And then you've just pulled that side across. Don't use that side again. Either you may be able to get 2 out of 1 by tilting it, then throw that away. Because you might pick up dust and grit. What I like to do is kind of roll it a little bit as it's coming across, so you kind of, even as you're moving it across, you're taking away. But the weight of the cotton ball, nothing more, because you can scratch it with that.
So would you say one wipe across and you put it away?
Pretty much, yeah. So never wipe twice. So if a bit of the cotton ball has touched the surface, throw it away. Now, a bag of like 400 balls is like about $3 or $4. So don't spur them, right? If you go through a bag cleaning one mirror, hey, you're still winning, right? You're still winning.
And would you use like disposable gloves for handling that?
I would absolutely wear gloves. Certainly, if you do contact the mirror, you're not going to get oils on there. But with a bit of a caveat, wearing gloves can make the mirror harder to handle. It can make your hands slippier or not as responsive. So, yeah. And then there's a second caveat, actually, because there's another way to clean your mirrors, believe it or not, and that's with your fingers. So under the water, under your foam, you're actually not really going to get the oils on your mirror. So a lot of people swear by this. Go Google it. There are YouTubes and there's articles about it. One way you can do this, instead of using cotton balls, is just literally lightly feel, and you can probably get rid of things using touch. I don't like to do that. I think there's too much risk in there, but it's certainly a thing. People do that. Obviously, take wedding rings off, things like that. No jewelry. Through this whole process, take your watch off, take wedding rings off, take anything that, if you've got long sleeves, put a t-shirt on. Nothing that's going to fall on your mirror. You don't want to wreck your mirror. And when you've done all that, if you're happy and it's rinsed, and you've rinsed it off and it's looking a lot cleaner, then you've got to be a little bit worried about how do you finish off, because you don't want water spots on there. You don't want it to dry really badly. So after you use your cotton buds, demineralized water. So demineralized water, get this from, this is Super Cheap Auto. Here's one I brought earlier. Super Cheap Auto, about $10 for whatever that is, 5 liters. That hasn't got any minerals in it. So if that evaporates, it's not going to leave a watermark, a water tide mark. Can still get rings from what was on there originally, but rinse it off with some of this. So that's really good to have in your kit.
Can you use distilled water?
So yeah, it is essentially distilled water, but the problem is where you get your distilled water. So the big warning I'll put out there, and I get this question every so often, is, oh, the water in my dehumidifier is distilled water. It's been distilled out of the atmosphere. Can I just use that? Well, absolutely not. The worst thing in the world you could use, because along with all the water that's evaporated out from your atmosphere is all of that dust and crud out of your atmosphere that's gone onto the coils, the evaporator coils of your dehumidifier. So don't use that. Don't use condensate out of an air conditioner. Go buy it. You know, your telescope that's worth $1,000 or $10,000 is worth $5 for 5 liters of water from Super Cheap Auto, right?
But usually distilled water is cheaper than demineralized.
Yeah, so just be careful with that. I mean, demineralized is best because it hasn't got any minerals in it. So you can get distilled water that still has some trace elements in there. So that's designed to go in batteries so that it doesn't clog up batteries. It doesn't. So I would always use that. So, I mean, you can get away with not using it at all. Our tap water in Auckland actually is not that hard. So you might just get away with just rinsing it and it's fine. In a pinch, if your telescope's really dusty and you want to go out observing, yeah, you're just touching it to the moisture and it will wick up into there and it will dry. So it should dry pretty clean when you do that.
Steve, what about isopropyl alcohol? I hear people watering that down and using it.
Yeah, so if your mirror is really, really dirty, you can use ISO. I've got some here. See, I brought all the toys today, all the props. So isopropyl alcohol, you buy that in Mitre 10, Bunnings, pretty much anywhere. Don't buy it from the chemist because they'll charge you $20 for 100 ml. So you go on the internet, it says go to a chemist and buy isopropyl alcohol. I did that once. First of all, I got 20 questions. What are you using it for? What is it for? Oh, I clean optics. What do you mean by that? Can I take your name and address? This was to buy a 70 milliliter bottle, literally that big, of isopropyl alcohol, and it would cost me like $15. And I was like, oh my God, I feel such an idiot. So then I went to the hardware store and bought a liter and nobody asked you any questions. So,
That's chemistry mix.
sorry?
Chemistry mix. It's isopropyl.
It's not meths, no. So this is isopropyl alcohol, meths is methyl alcohol. Different. Similar, it's an alcohol. Isopropyl is probably safer for more coatings and things. Some manufacturers recommend using up to 50% of this to clean their mirrors. If you can get away without using it, get away without using it. If it's really dirty, you can't get it off. I mean, this is going to absorb some organic things. So if somebody's, if you've managed to get paint or marker or something on there, then this might work on getting it off. So yeah, you can use it. It's fine. You know, I've got it for cleaning telescopes. That's what I use it for. But if you get away without using it, why not? The one thing that you could do is in final rinse, if you're struggling to rinse it, actually some alcohol in with your water will help the final rinse evaporate off. So that's one little tip.
Have you ever watched a little circle off?
That's the other risk of using a solvent. So if you're going to use a solvent, you can get rid of the little spot in the center of your mirror. So to be careful with the strength of your solvent. Now when you're buying this, it's got different names: rubbing alcohol, surgical spirits, IPA. What it doesn't often say in big letters, although sometimes it does, is how much of it is in there. Sometimes you'll buy rubbing alcohol and it's only 40-50% alcohol. You really want buy 99% alcohol, because if you don't, you're buying a lot of water. You can dilute this yourself with some of the your Super Cheap Auto demineralized water.
Methylated spirits is now ethyl alcohol.
Yeah, that's right. It is. Yeah, you're right. It is.
And I guess you wouldn't clean with it.
You wouldn't clean with it, and there's additives usually in it. Yeah, that's right. So isopropyl is what I would recommend. That's the safest for most things. However, having said that, the process sometimes, the process for getting coatings off things is to soak them in alcohol, such as isopropyl alcohol, for a number of days. So be aware that it is going to soften your coatings if you're going to use alcohol, which might make it harder to clean or more likely to scratch. So there's a lot of caveat emptor here, so you've got to be aware of that. Other optics, so other than mirrors. Any other questions on mirrors, actually, before we move into other optics, which is very, very similar to mirrors, really. So, okay, other optics. Your binoculars, the corrector plate on your SCT, eyepieces, filters, all of that. Same rules, first off. Don't blow on it. I have seen some guides that recommend sucking them, actually. I don't think it's going to work very well, and all that crap's going to go in your lungs, but, excuse the French. One recommended way of doing it is to put a couple of fingers over here and go, and to try and suck the air off, suck any dust off. Guess if you're stuck in the field with nothing else, could work, but I don't want to really breathe whatever's in there, particularly not if it's somebody else's eyelashes and things like that. But one thing with these is, you're going to get oils on these. Your eyelashes have got oils on. These eyepieces are meant to be cleaned. Mirror infrequently. If you're cleaning it more than once a year, you probably need to look at your storage regime. But an eyepiece, very easy. You're swapping them around. You put them in your pocket. They get fingerprints on. Kids put the fingers on them. You get eyelashes on there. The oils from your eyelashes go on it, so you do need to clean them. Same rules apply. Don't blow on them. Don't use brushes. Don't be cautious with canned air. And definitely use those blowers. But there is a secret recipe that you can use as a cleaning fluid. Oh, sorry, that's the wrong secret recipe. That's the 11 herbs and spices, if anybody wants them. Yeah, this is KFC's secret recipe, apparently, allegedly. No, the secret recipe is, unsurprisingly, this. Unsurprisingly, this. And probably unsurprisingly, this. Or maybe this. Because we all go to Costco and we all have it, right? What do I mix it in? My recipe that I use, and it isn't my recipe, it comes from our prior curator of instruments, Graham Beasley, who taught me this one, and it works great for most things. 70% water, 30% alcohol, couple of drops per litre. Maybe 3 or 4 if it's not working well for you, but 1 or 2 drops per litre. I have always got a bottle of this. I label it mix, a spray bottle. 30% alcohol, couple of drops of liquid. And I use it for all sorts. I don't just use it for cleaning optics. It's actually really good for cleaning the TV, cleaning my laptop, cleaning everything. Just because you've got the water in there, which isn't going to smear. You've got the alcohol in there, which is going to dissolve some organic molecules. And you've got the dish soap in there, which is a surfactant, and it's going to get rid of any greases and oils. So it's actually really good, super gentle. It's only 30% alcohol, so it's not really going to damage anything. And then I've always got a bottle of straight demineralized water as well. Along with that, along with secret recipe, along with the 11 herbs and spices of telescopes maintenance, talked about cotton balls. Absolutely, they're great. Plain white tissues. Always got some of those, although I didn't bring any with me tonight. Caveat for those, there's lots and lots of warnings tonight, but the warning for that one is careful what you buy. Obviously, again, you don't want anything that's got moisturizers or menthol or anything like that. But I also stay away from recycled tissues, because recycled tissues have been through a lot of processes. There could be fragments of glass in there, microscopic fragments of dirt or dust. So it depends on the process. So typically kind of look for, like sustainably sourced or whatever, but the kind of tissues have been made from virgin wood and just white tissues. And they work great, but they do leave a bit of dust. So be aware of that. That's what you've got your bulb blower for. Get rid of the dust. You can use these as well, chem wipes. So they are laboratory wipes. They don't leave a residue. I haven't got any with me, unfortunately, but they're expensive. So, you'll pay $2 for a box of tissues, and you might pay $15 for a box of chem wipes, depending on where you buy it. You can buy them from NZ. Oh yeah, Office Max, they sell them now. Last time I tried to buy some, they didn't have any. Office Max, you can buy them from NZ Safety Blackwoods, sell them at a reasonable price. You can go to some camera shops and you'll pay twice what you'll pay anywhere else for them. But Kim wipes are good. A little bit more abrasive. Be aware of what you're doing. Be aware of the pressure you're putting on. Again, if you're not putting any more pressure than the weight of whatever you're using, it's going to be okay. So kind of the process to clean it, and this is coming to the end now, so you can breathe a sigh of relief. Here's kind of the golden rules, and this kind of suits everything, right? Don't put the solution directly on your optics. Now, I haven't talked about that actually, but it's a really, really important point, particularly if you've got a refractor with stacks of lenses in the end of them. If you get your happily prepared mix here and you go squirt, 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 squirt all over it, what's going to happen is this liquid is going to seep around the edges of your lens. It can potentially seep inside lens pairs or triplets. It can potentially take dirt inside those lenses, and you're going to really struggle getting them out without a full disassembly. And if you disassemble them, it's going to be very hard to put it back together in a working state. So always squirt so whilst I've got these in squirt bottles, I should reiterate, don't spray onto the object itself. Kind of one thing you can do, one thing I do sometimes is when I'm cleaning a mirror, is to actually use the spray bottle to get a little bit of extra kind of squirt on the, although you can just use the tap. So always put the solution on, don't put the solution on your optics, put it on whatever you're cleaning it with. Dab, don't wipe. So the action that you're looking for when you're cleaning something isn't I'll leave the cap on here, isn't this. We're not looking at that. What we're looking at is a dab, turn to a new fresh part, dab, turn to a new fresh part, dab, throw it away. Get another one, dab, 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 throw it away. Once you're really absolutely sure you've got everything off, you might need to give it a slight wipe to get any sort of smears, to get, and again, just the pressure of the pad if you can. With an eyepiece, you can be a little bit more aggressive, but I would advise not being. Just the weight of it. Just try and get in there. So dab, dab, dab. When you clear it, when you're sure it's got rid of all the dust and grit, then you can give it a gentle wipe. So that's the other rule. Lightest of touch, the weight of the cotton or the tissue only. You might find with an eyepiece that you get some stubborn marks that you do need to put a little bit of pressure on, but absolute minimum. It's easy to scratch coatings, it's easy to damage optics. Never use the same section. Sorry, Robert? Filter's the same. So really any optical surface, be that your corrector plate, be it a filter, be it an eyepiece, be it your binoculars, the objective of your refractor, really the same.
Is there a certain era of... I've got some very old filters, or an old... Should I be wary of how they're made? I know that if you had old mirrors, they might not have their own element coating, so
yep.
You'd have to keep it there.
That's why you're as light as possible and you use it as gentle as you can. So if you don't, if you've got something that's old and you're worried about what it's coated with or how it's made, maybe you start with just water and a little bit of Dawn, a little bit of dish detergent to try and get it back to where you want it to be before you put any alcohol on it. In general, that 30% mix shouldn't really affect anything. You should be able to go to 100% for a short period and it should be fine. But, if you've got something that's really valuable, has got a sentimental value, you don't know what it's made of, it's really old, be very cautious. It's kind of,
Are there places that you can take them to that professionally do that, or they sort of say, well, we'll do our best and no guarantee?
Pretty much everywhere is going to say we'll do our best and no guarantee. There may well be some very expensive places that you could send them to do that. I don't know. Grant might know, but no, he's shaking his head. I don't know of anywhere. There are plenty of places that you can go into sort of camera shops and things like that. You clean sensors for a living, and they'll say, hey, but nobody's really going to give you a guarantee. Particularly if you don't know what it's made of, they don't either, usually. So, yeah. Be aware. I mean, if something is that dirty and it's that precious and it's that old, maybe it's time to put it on the souvenir shelf and go and buy a cheap Chinese-made one that you can replace it with. As I said before, never use the same section of tissue or cotton bud twice. You may have picked up some grit. On the very next swipe across the surface could scrape it if you do that. And then I said before, use a corner of a tissue to suck up any sort of residue, any water left over. It's kind of my sort of cleaning.
The corrector plate is quite a large thing.
Yep.
8 or 10 inch. Once again, you're going to just. I've got a few finger marks where the secondary mirror.
Yep.
You get finger marks here. You're never going to get it off doing that, are you?
You'd be surprised. So use the minimum touch you need.
So still dabbing even on it?
Still dabbing. Well, until you know there's no dust. Once you've been across the whole surface with wet and you've taken it off, you're pretty confident, and actually you'll feel it. So if you do this, and do it on something, do it on an old eyepiece and have a go. When you first do it, you can, even when you're dabbing, you can feel the resistance of the glass when it's dirty, and you can feel that it's a lot less friction as it gets clean. So it becomes a bit of a touch thing. And, you know, if you've got fingerprints that need to come off, you may need to put a little bit of pressure on, but use the minimum pressure you need to get the job done. I cleaned the mirror for the Zeiss telescope when we did the overhaul back in 2019, and it with all the moving about and craning in and out and things like that, even though we took the mirror out, there was quite a bit of dust on there. That is an aluminized mirror with no overcoat on it. So there's a section of the mirror on the outside which is always covered up. So in order to give myself a test on how much pressure can I put on this before I'm starting to damage it, because there was some quite stuck on crud on there that I was trying to get off. The answer was almost no pressure at all. Even with just pretty much the weight of the cotton that I was using, you could scratch the aluminium. So most mirrors, most correctors, I mean, correctors are actually made to be cleaned. The coatings are not really, really delicate. They're just delicate. So, you know, you're probably going to be fine.
Generally, most mirrors these days will have a silicon dioxide overcoat.
Yep.
But if you've got an old one, it may not.
So the thing to keep in mind is if your mirror's a little bit dirty or a little bit dusty, you can always clean it. If you scratch it, you can't fix it. So use that in terms of when you're thinking about when and how often to clean your mirrors. If you're really confident, some people do. Some people clean the mirrors every 6 months. They'll take them out, they'll put them in the sink, they'll wash them and put them back in. Once you're confident, absolutely do that. But be aware, every time you take that mirror out and handle it, the chance that something's going to fall on it, that you're going to drop it, that it's going to slip in the sink and you chip the corner of it, it's all in there. So that's kind of it.
What's the life of the coating?
So life of the coating, I mean, it sort of depends, right? I mean, it's silicon dioxide. It'll last probably till the end of the earth, really. But it depends how much you scrub on it. If it's the optical coatings, they will break down, probably, but it'll be things like UV that do it, and we don't use our equipment during the day mostly. So solar telescope may be different. Hard to say. Usually over cleaning is what, if you look at an old telescope that's got coatings on, a lot of old telescopes actually don't have coatings on, sort of, you know, the kind of 60s or 70s, 80s ones, a lot of them are actually not coated. But as you start to get into the coatings in sort of 80s, you tend to see sometimes the ones that have been cleaned heavily, it's starting to flake, or it's been in a very hot environment, you can see it starting to flake. And I have seen people, there is a YouTube or it might have been an article that I read where somebody did strip the coating because the coating was really bad. So they soaked it in isopropyl alcohol for about a week and stripped the coating off because the coating was in such bad condition, and then polished the glass. So again, it depends how the telescope's used. If you're using it and looking after it, it should last the life of the telescope. You'll probably break something else before the coatings are gone if you look after them.
Storage of your telescope in an observatory, if it's inconvenient to
Yep.
the telescope all the time. Do you have any recommendations around that? Wrap the telescope up in a towel or something?
Cover it from dust. If you've got a lot of spiders and things like that, try and stop the spiders going in. If you get rodents around, which happens everywhere, be aware of any comfy places that mice might want to nest. Keep your mirror that way, keep your telescope horizontal, keep your mirror upright, so anything that is going to fall on it is not likely to settle on the mirror. That's probably the biggest ones. In an observatory where, so the research observatory, Grant's one here, he operates remotely, so it's not covered all the time. It's Schmidt-Cassegrain, but Grant, the balancing act for Grant is he knows he's got to clean that more often. So he leaves it open so that he doesn't have to come here to start it up, but he knows he's got to clean it more often. So it's sort of, again, horses for courses.
You mentioned briefly camera sensors.
Yes.
In terms of training?
Same thing, really. Camera sensors, very sensitive, just like the coatings. You know, the slide I had back there about don't do stuff, you know, that holds true again. You get kits for camera sensors which have got essentially a piece of absorbent material on a stick that you're supposed to put alcohol on and wipe it across the sensor. I wouldn't ever do that unless I'd use my little puffer to get rid of all the dust.
Sort of like for photography cameras, you've got a white thing and you've got
That's it, yeah.
to drag it across,
Yeah.
which is scary.
It is scary. They've got to be wet. So that same, if you read the instructions, they say it's got to be wet. And the reason is because the same reason I say wet your cotton wool, exactly the same reason. If it's wet, it's less likely to scratch. It's lubricated. Same thing. But I would always get my little bulb blower and give that a good puff out before I even start a process like that. I have absolutely cleaned the sensor on my camera. I've used one of those little wipe things. It is scary as hell when you spent thousands of dollars on a camera and you're sticking something in the sensor that all your intuition tells you shouldn't touch. But it is the same thing. It's really the same sort of thing.
I've got a little tip. If you've been out observing a really often highly dewy night, when you come in, your eyepieces are going to be cold. And you put them down, as soon as you come into a warm environment inside, which is much higher humidity, you'll see that you'll get condensation on the eyepiece straight away. So don't put them away while they're wet, basically. Because if you do that and stick them in a box or whatever, you're going to get mold growing on them.
And that goes for your telescope tube as well, actually. You bring your dob in after observing. Sometimes I've brought them in and they are soaking. Don't stick them in the box and close the box, or stick them in a bag and close the bag. Leave them out, let them dry off, and then close them up. And that's, again, if you do photography, that's the same thing. If you use your lenses in the rain, you let them fully dry before you put them away.
Well, Steve, you can get a humidity and temperature control cabinet for your photographic equipment.
You can indeed. So,
in that as well.
Yeah, absolutely. If you've got, I mean, even actually just an airing cupboard, you know, a hot water cupboard, you can keep them there, which is very dry air in general.
But it's also those damp rid and those things. I mean, you know what it is.
Yep.
Silica things.
Silica gel is great. Yeah, you can get those. Cheapest way to buy silica gel is often in those packs that they're designed to go in damp wardrobes, and they don't work in damp wardrobes because they're not big enough. But they do work in your telescope box, and way better than a lot of people kind of hold on to those little sachets. I mean, they're useless for something the size of the telescope. But a couple of those big damp red things, you can buy them cheap from the $2 shops and things. That's just silica gel, and that helps keep the moisture off. So absolutely, moisture is one of your enemies. Cool. Any questions for online, Eric?
Not that I can see. Yeah, no, nothing on the chat.
Cool. Any more questions?
Well, just with eyepieces and how they fog up more than mirror does.
Yeah.
What's your advice for keeping them clear on a cold night?
Same sort of thing. I mean, it depends on the value of your eyepiece, right? If you're out doing outreach and you've got, a $30 eyepiece and you've got a line of kids who want to see Saturn, I'd be tempted to have one where you use a microfiber cloth and clean it. I know that goes against everything I've said, but if you've got a low cost eyepiece that isn't, you've not spent $600 on it, you can buy another one for $30 or $40, and you use that with kids, for example. I'd have a microfiber cloth and just give it a gentle wipe. And I think that's fine. I think same with binoculars. Use your judgment. How much did you pay for your kit? How much you want to really look after it? If you've got something that's premium, you want to do only the premium things. So the answer is, if you've got a $600 eyepiece, you probably want to leave that inside until it's dried out. If you've got a $60 eyepiece, you can probably have a little bit more latitude on what you do with it. So, yeah. Sorry? Yeah, you put it there. I mean, if you you could put it just inside the house for a little while, swap eyepieces, put it inside the house, put it inside the observatory, put it inside your car with the heater on, let it dry off, and then use it again. You can carry your bottle of secret recipe with you, and some cotton buds and some tissues, and you can give it a quick clean. So it all depends where you are. If you're out and you're actively observing, you can see you've got a line of kids, you might make a different decision to if you're there all night anyway and you've got all the equipment with you. Yeah, not one answer really, but what feels right. You're not likely to wreck an eyepiece by cleaning it once or twice really carefully, but as I said, if you spend a lot of money on it, you want to be sure that you're not going to wreck it, right? Cool.
Some of these teleview eyepieces cost around $1,000 New Zealand.
That's right. Yep. So a $1,000 eyepiece, I probably wouldn't be getting a microfiber cloth out of my pocket. But, you know, hey, there may be people who would, right? So, but yeah. All right. Thanks, everybody. If anybody wants to see the collimation thing in a little bit more detail or anything, just, yeah, I'll hang around for a while.
So the movie that's on next week is called Mysteries of the Universe.